So let's talk about the definitions of basics and derived. So first we'll see the definition of basic physical quantities. So basic quantities are independent. They cannot be expressed or formed by others. What is the meaning of this line? Basic quantities are independent. They cannot be expressed in terms of others. Okay. So for example, if you have length L. So if you have length, you cannot determine the time. If you have time, you cannot determine the mass. If you have mass, you cannot determine the current flowing in any substance, if it is conductor. So these quantities are the examples that these quantities cannot be expressed in terms of others. Length cannot be expressed in terms of time. Time cannot be expressed in terms of mass. So these are the basic physical quantities. And what is the definition of derived? So simply, it's opposite to the basics. Derived quantities are dependent on basics. They are not free from each other. They are dependent on basic physical quantities. For example, if we have F is equals to ma, force is equals to mass into acceleration, then force depends upon mass and acceleration. So force is a derived physical quantity. So students, here we have some examples of derived physical quantities. You can see here the name of derived physical quantities, and here we have a formula of them in which we can see that these quantities are dependent on other quantities because we are using formula from them. Pressure, for example, pressure is equals to force over area. It depends upon force and area. So definitely it is a derived physical quantity. And what about force? Force, here it is given. Force is equals to mass into acceleration. So definitely it is also kind of derived physical quantity. And what is acceleration? If you'll see, acceleration is given in the fifth number. Acceleration is good change in velocity over time. So definitely it is also kind of physical quantity, derived physical quantity. What is velocity? Velocity here, distance over time. So ultimately it depends upon basic physical quantities. So how many basic physical quantities are listed by Stern Institute? Let's see. So you can see here 7 basic physical quantities are listed, and these are length, mass, time, Kelvin, or you can say temperature, candela, mole, and the last one is current. So these 7 physical quantities are listed and you have to write in your notebook. And some special notations are used to denote these quantities. For example, length is represented by capital L, mass is represented by capital